Hello and welcome to Solving Quadratics by Factoring. Today we're going to go over what is sections 16.2 and 16.3 in the textbook. We've gone over 16.2 already. 16.3 is very similar to 16.2, but just one extra little step that you'll find out soon enough. But anyways, when we are focusing on solving quadratics by factoring, there is a core idea that we need to remember. And the core idea is this. A times B equals 0 only if A equals 0 or B equals 0. And so what we end up doing with a quadratic is we take something that's in the form ax squared plus bx plus c is equal to 0, and we try to break it down to where we have two binomials being multiplied together through factoring in some way, shape, or form. Because this one right here essentially is like A, and this one right here is like B. And once we've separated them out into their two factors, we can then solve each one for 0 because that's what it says. A has to be 0 or B has to be 0. So let's do some examples to make sense of this. First one is this. X squared plus 5x equals 0. Again, I want to stress what we have is an expression with an addition sign. That doesn't help us out too much. What we want to do is get this into that form of A times B equals 0. And the way we'll do that is by noticing a common factor between our two terms. And so we will extract it, which is x, and then we have x times the quantity x plus 5 is equal to 0. We now have A times B equals 0. And so the next step here is to take these two factors and split them into two separate equations. X equals 0 or x plus 5 equals 0. The one on the left is already done. The one on the right, you have to subtract 5 from both sides. And we end up getting x equals 5. Negative 5. And so those are the two answers for that one. Let's look at another example, but let's kick it up a notch. Okay, let's try this one. 4x squared minus 3x equals x squared plus 3x. Now the thing that we have here is that we don't have a 0 yet. Alright, so my goal is to get a 0 on one side of that equal sign. And so I need to move a few things over. So I'll subtract x squared. I'll subtract 3x. You gotta be careful when you subtract the 3x because notice that these are not going to cancel each other out. You're actually going to get negative 6x, and then you'll have 3x squared equals 0. And now it looks like the previous problem where we'll factor out a common factor, in this case 3x, times the quantity x minus 2 is equal to 0. We now have A times B equals 0. So what we'll do is break these off into two separate equations. 3x equals 0, x minus 2 equals 0. And again, this comes from that rule, A times B equals 0. If that's the case, then A has to be 0 or B has to be 0. And then I do a little bit of work to solve. So divide by 3, x still equals 0, add 2, x equals 2. Okay, so now that's just when we factor out a common factor. Let's now look at an example where we have a trinomial. So here we have a trinomial. X squared plus 5x equals negative 6. It doesn't quite look like a trinomial yet, but we do. Now, I have it written like this to emphasize a point, which is that at the very, very beginning, we have to set it equal to 0. All right, if it's not set equal to 0, that rule does not work. So that just means we have to add 6 to both sides. So now we have x squared plus 5x plus 6 equals 0. And again, what we have here is an expression with all these plus signs that do not help us. We want it to make it look like A times B. So we factor it. X and x. We now look at that final number, C, and we have a couple of options. We have 6 and 1, 2 and 3. 2 and 3 are the ones that work out because we have to have the same sign because of that sign, and then we have to have a positive 5. And so when we do the outside-inside terms of FOIL, we'll get 3x and 2x for a total of 5x. So all that equals 0. We now have a times b equals 0, so we'll take this part, make its own little equation, take this part, make its own little equation, x plus 2 equals 0, or x plus 3 equals 0. And so you solve, x equals negative 2, x equals negative 3. And there we go. All right, so now I have 2 more examples for you. And again, we're going to just kick it up a notch. And so this is more where we get to mod 16.3. The difference with mod 16.3 is now we're going to have a coefficient here. All right, so I mean, it's the same game. What we need to do is take this expression and turn it into a multiplication problem. All right, once we've done that, we're good. So now that I have a 3 here, I'll put a 3x down here and an x there. Then I got to pick some factors of 20. 4 and 5, 2 and 10, 1 and 20. I'm going to start with 4 and 5. I think that's probably a good spot to go with. So let's go 4 here, 5 there. Let's see here. If I go minus 4 plus 5, I'll get negative 12x plus 5x for negative 7x. So I now have my binomial. I've factored it. Split it up, and I like to kind of draw that line to really emphasize that we're cutting this thing in half, and we're now going to do 2 separate equations. 3x plus 5 is equal to 0, or x minus 4 equals 0. And here, we just have a little more work. I mean, on the other ones, the most complicated thing we'd get is something like this x minus 4, where we add 4 to both sides, and we say x equals 4. Now, we'll have to do just a little more work. All right, we'll subtract 5 from both sides, subtract 5 from both sides. 3x equals negative 5, divide by 3. And here we'll get some fractions as an answer. So x equals negative 5/3. So those are our 2 answers for this one. And so that's this right here is the difference between 16.2 and 16.3. That when you factor it, you're going to have to do a little more work to solve it. All right, one final example for you. Okay, just want to show you, again, has to be equal to 0. So the rule all this is based off of is a times b equals 0. That's not equal to 0 yet. So subtract 2, and now we're looking at 6x squared minus 17x plus 12 equals 0. Now, when you have a larger coefficient like you do here, try to check to see if there's anything you can take out of all 3. And unfortunately, we can't. So now it's just playing that guess and check game. And I'm going to kind of cheat a little bit because I made this trinomial. So I'm going to just randomly guess, hey, I'm going to put a 2x here and a 3x there. And I don't know, I'm going to play some factors of 12 and, minus 4 and minus 3. Let's see. Minus 3 and minus 4 will make positive 12. This will give me negative 8x. This gives me negative 9x, negative 8, negative 9, negative 17. What a coincidence. It all worked out. Anyways, all right, so it might take you a little more work to actually factor these straight up when you're coming across a new problem. But that's what you have to do. You factor it, and now we separate into 2 separate equations. So here we'll get 2x minus 3 equals 0, and over here, 3x minus 4 equals 0. And just to stress it again, we have a times b equals 0. That's why we're doing all this factoring. Then we break up the 2 factors, a equals 0 or b equals 0. It's just that a and b are these expressions. So going back to solve, you're going to get some fractions here. So we'll add 3, 2x equals 3, divide by 2, x equals 3 over 2. Here, add 4, and make sure to take your time with this. I mean, this is not terribly complicated, but there's a ton of room for making silly mistakes. So take your time, show your work, and x equals 4/3. And so the thing that we're going to get here is we're going to get a lot of answers that double up. The only time we're not going to get an answer that doubles up is if we have something like a perfect square trinomial. If we're looking at something like x squared plus 10x plus 25, because when you factor that, you'll get x plus 5, x plus 5. And so in this case, if you were solving it, your answer would just be x equals negative 5 twice. So, but again, the process is you just factor it, you then take each factor, set it equal to 0, solve it, and those are your answers. Hopefully this clarifies a lot of this stuff for you. If you have any questions, don't hesitate to reach out. I'm here to answer any of those questions you may have.